Test 1 2 3. Test 1 2 3. Test 1 2 3. Test 1 2 3. Voice test. Voice test 1 2 3. Hello everyone, I'm Ryan, Webmaster Sales Director. This time, I'm going to introduce the Webmaster the Smart Parking Sensor Solution. Today's topic will include the parking sensor PS102 series and the WR322 LoRaWAN gateway, Webmaster Smart Parking Sensor Solution, and last, a demo about the LoRaWAN parking sensor in this webinar. We are using the YouTube Live to broadcast. During the presentation, if you have any question, please type in the chat room or mail to us. We will reply after the presentation. Come with the popularity of the IIoT. It indeed provides the people's life more convenient. Smart parking solution is started up by this chain. Visitors can find available parking lots faster and easier. By real-time parking data, people can locate their parking lot and even combine other solutions like the CCTV payment system to provide more service. According to the Granting Tribune research, the U.S. parking system market size achieved $3.9 billion in 2019, come with the growth rate of 70.4% per year from the 2016 to the 2027. It's getting to be a huge market, and this kind of the solution is the trending to the world. Now, I'm going to introduce the Webmaster Smart Parking solution. Currently, we can use the two-way of the LP when the connectivity send the data back to the monitor platform. One is the NB-IoT. Another one is the LoRaWAN. In the following slides, we will brief the details. In this page, I just highlighted some differences. Firstly, if the users choose the NB-IoT one, the SIM card service and the monthly fee are necessary. The related model is the PS102-USGM-NB-BTA-SB. And however, some of the customers concerns the operator service for the security or the monthly fee. Then they can consider the LoRaWAN. For the LoRaWAN gateway is a portal to collect all of the data to the platform. So that it's necessary but it doesn't need the monthly fee, and the related models are the PS102-USGN-LR-BT8-SB for the parking sensor, and the WR312G and the WR322GR-EC series for the LoRaWAN gateway. In there, you can see WarMaster provides the different options for the different needs. In the following slide, we will go into more details for these two solutions. First, let's talk about the LoRaWAN solution. This page shows the architecture of the smart parking LoRaWAN solution. In the right-hand side, the first one is the WarMaster parking sensor PS102-US-GM-LR-BTS-SB. It will send parking information to the LoRaWAN gateway WR322GR-EC-LTE-LoRaWAN over the LoRaWAN protocol. And WR322 will collect this information to transfer to the MQTT protocol to the WarMaster cloud platform, since master OTA, over the LTE or Ethernet. If the security concern, the LoRaWAN data can be encoded by the AES-128 encryption. By this way, users can monitor the system from the platform, since master OTA. Of course, this system also can combine the different LoRaWAN solutions, just like streamlighting, trash bin sensor, or the environment monitoring. This LoRaWAN data can be collected to the gateway and send the platform once. Therefore, WarMaster can provide various and complete IIoT service. You can treat it as a smart city solution. Before I introduce the products, I would like to share with you about the LoRaWAN network. Regarding the LoRaWAN, it's using the star architecture to build up the network backbone. So all end devices will send the data to the central gateway. The gateway will collect the information to push back to the network server and the application server over the backhaul. Of course, there are many options for the backhaul, just like Ethernet, LTE, or any connectivity. Regarding the LoRaWAN's data rate, it's used for the lower the data rate application, just like environment monitoring, smartphone, or smart parking. High traffic flow application is not suitable for this wireless connectivity. Usually, the data rate is between the 300 bps and the 50 kbps. It's changed by the real environment or distance. And it supports bidirectionally the communication and the multicast addressing. Some of the users choose it for the cable replacement. They would like to extend the transmission distance. From the technical spec, it can support under the 10 km. However, for the reliability and the stable concern, we suggest that 4 to 5 km is the limitation. As for the network scope, It can support around 200 nodes maximum for a large network scope. Now, let's move to our LoRaWAN parking sensor and gateway. For the WorldMaster LoRaWAN parking sensor, PS102-USGM-LR-BTA-SB is using the ultrasonic and geomagnetic to detect parking lots. They have the different detection interval. Geomagnetic is the 10 seconds, and the ultrasonic is the 10 minutes. It supports the IP68 and the surface mount. There are the different LoRaWAN bands for the options. High temperature supported. Battery is the 8500 milliamp, 3.6 V, and the lifetime is around 2 to 3 years. It has the work with the LoRaWAN gateway WR322 series. As for the LoRaWAN gateway, there are two models, WR322GR-EC-LT-LoRaWAN and WR312GR-EC-LoRaWAN. WR312 supports the LoRaWAN LPWAN connectivity in the wireless interface only. For the WR322, it supports not only LoRaWAN but the LTE interface. It built in the LoRaWAN server and support MQTT so that users can use it to connect to the cloud server as a gateway. It also supports a different interface, just like the serial ports. LTE Cat4 or Cat6 is optional. LoRaWAN and 2 gigabit Ethernet ports too flexible to build up the application. It also supports different security ways to protect the application from the different perspectives, such as the OpenVPN and IP6 for the data tunnel, HTTPS and SSH for the security login. Moreover, if users can program, it also can offer the OpenWRT platform. Users can use GCC toolchain or NodeRED to develop which the function they will need. Next, users can choose the open cloud platform like AWS, Microsoft, or else, or private cloud platform provided by the WorldMaster SysMaster or SysMaster OTA. Here you can see this picture. We collected the sensor data from the sensor by the LoRaWAN, and some environmental data are shown in here. They are used for the analog monitor, not the control. After the LoRaWAN product introduction, let's see the typical parking sensor architecture for the NB-IoT connectivity. As you can see, NB-IoT parking solution is the major solution here. We base on it to combine the others just like kiosk for the payment, LED for the parking information system. First of all, NB-IoT, the parking sensor PS102-USGM-NB-BTA-SB can transmit parking data to the platform, SysMaster OTA, over the NB-IoT connectivity. And we use the industrial switch to build up the network backbone in the parking lot. Of course, if users prefer the ring topology, it also workable and provide redundancy. All devices connect to this backbone over Ethernet, just like kiosk or the LED panel. Therefore, we can collect the platform and publish the information to the end devices. For some locations which are hard to wire, we also can use the wireless router to send the data back to the platform over LTE or Wi-Fi. Combined with the parking sensors, we can provide a complete parking solution. Today, we still focus on the parking sensor parts. In this page, it's going to show you the NB-IoT, the parking sensors PS102-USGM-SB. Basically, they are using the same form factor and the features with the LoRaWAN 1. The major difference is the communication way only. And there are many NB-IoT bands for option for sure. And it's using the micro SIM card built in it. Moreover, it doesn't need any the gateway and the work independently. We just share with you the parking sensors with different connectors. We are going to show you how to configure the devices and how the solution working. Today, we will use a LoRaWAN topology to demonstrate it. The scenario is like this page. First of all, we need to configure the parking sensor over the UART. We can use the utility to change parameters in the PS102. Then, we need to configure the LoRaWAN gateway or routing over the Ethernet. We can use a login its web page to change the setting of the WR322. After it, we will show you how the whole solution works. Okay, let's see our technical support Patrick to demo the WebMaster parking solution.
Hello everyone, I'm Patrick. Today, I will show you how to receive the parking sensor data in WR322-EC and display in our OTA platform, ThinkMaster OTA. Okay, this is our demos today. We have a parking sensor communication to WR322-EC through LoRaWAN. And our computer use the Ethernet cable connect to WR322-EC. And also, we can configure the parking sensor first through the USB to 3-pin UART cable. For example, you can change the upload interval and other settings. Okay, you can refer the user manual of parking sensor to configure the parking sensor. And in this page, we open the parking sensor case to show you how to connect the cable. You can see we need connect the battery and the capacitor and a a 3-pin UART cable if you want to make some configuration. The 3-pin are TX, RX, and the ground. You can find the serial parameter and the pin assignment in the sensor datasheet or user manual. By the way, we can use the magnetic in clockwise direction to reboot sensor, so we don't need remove battery every time. Okay, now we start to edit the parking sensor info in the WR322EC. We need to open the browser and input the HTTP and the IP address of WR322EC and the port 8088. Then we click LoRaWAN server and click application and click edit application. You can see we have already added the application parking sensor. Then we can click devices button and continue edit the device. And we already added the devices parking sensor 01. You need input device EUI when edit device. And you can find it in the button of parking sensor. After edit the device, we click activation. Select join mode to the OTAA and input the application key that you can also find in the button of parking sensor. After you input app key, then click submit button. Because the minimum upload interval of parking sensor is 1 hour. So after configuration, we can use magnetic to reboot parking sensor to check it quickly. Then we back to the application devices to check the field. Let's see at. If you can see the timestamp here, means the parking sensor already connect to WR322EC successfully. And we have another choice to check the connection. We can open the browser and go to the CryptStack web page of WR322-EC to see the detail. The CryptStack web page is HTTP with the IP address of WR322-EC and the port 8080. And you can use the admin to log in the CryptStack page. And you can click the gateway and click the WR322-EC-LoRaWAN-default. Then select Live LoRaWAN Friends. Okay, so if you didn't see anything here, again, you can use the magnetic to reboot parking sensor. In slowly, you will see the LoRaWAN Friends uploaded by parking sensor and display here within 1 minute. Okay, next, we will go to the WR322-EC NodeRED web page with the HTTP, the IP address of WR322-EC and the port 1880. And you will directly see the default flow for parking sensor. We will explain how to process MQTT data in NodeRED. In the left side, you can see we have dragged a MQTT-in node. We can double click to edit this node. We need to change the topic. The format is application slash the ID of parking sensor slash device slash and the device EUI of parking sensor and with the slash sharp in the end. Okay. So we can back to the LoRaWAN server. The check application. You can see here is a parking sensor. The ID is 36, and here it's the device EUI of parking sensor. Okay. And after you change the topic, remember to click the done and deploy. And you can see we have dragged the two debug node here in green color. We can click the pull ring to active or deactivate the node. When we active the debug node, you can see the debug message to output to right side by click the bug icon. In first debug node, the message .payload. Every time when WR322-EC receive data from parking sensor, it will display in debug window. In second debug node, the after decoder, it will output the data after decoder. The original upload data needs translation to feed to SyncMaster OTA. The debug node will help to check the decoder correct or not. Okay, so now we use magnetic to reboot the parking sensor again. So you will see now the parking sensor will upload data to the NodeRED and display in the debug windows in the right side. Okay, so you can see the debug node, the debug windows display again, and this one is output by the first debug node, and the second one and is output by the second debug node. So now we're back to the PowerPoint file, and we will introduce the function node, the parking sensor decoder, in this page. The goal of the node is passing the upload data by parking sensor and transfer it, then output to SyncMaster OTA and display in SyncMaster OTA. First, we need to transfer the data stream from format base64 to hex. So this is the base64 string. There are many websites can help you. You just copy and paste. So paste here and click the convert base64 to hex, and the website will output the hex string for you. Then compare with the parking sensor data format that you can find in sensor spec or datasheet. And now we can start coding. For example, in hex string, we interested in the height. The height is air distance between the car and the sensor. So we check the data format. The value of height is in byte file. and byte 6. Remember, the string is start from byte 0 and the 2 words equals to 1 byte. So we declare a variable h to take out the byte 5 and the byte 6. Then you can see we use the same way to get the value what we want. The sample code is easy. You can modify it by yourself to fit different sensor. So we back to the previous page. So you can see after the decoder, there are 5 values in JSON format and the output to SyncMaster OTA. So now we go to the SyncMaster OTA. The NodeRED already output data to the SyncMaster OTA. Of course, we need edit a new device here. So we added a new device and named WR322-EC demo. And after we added this device, we need to copy the access token and paste in the NodeRED. The access token is unique. So after we copy and paste, so the NodeRED and the SyncMaster, they can understand each other. So in the end of the NodeRED flow, it has an MQTT out node. So you need to configure the sync information of SyncMaster here. Okay. So we double click to edit, and the topic is v1-devices-me-telemetry. This is the fixed topic. And in the server, you can use the edit function and input the server address of SyncMaster OTA, and the port is 8883. And remember, check the enable security connection and select the TLS configuration. And continue edit. So in here, in this page, you can upload the certificate file. Here, you can download this file in our Google Drive, or you can contact with our sales to get this file. So after upload the file, click the update. And in the security tab, we need copy the access token here. Okay. And after you pass the username, remember click the update and the deploy. Okay. So after you configuration this node, the NodeRED will make connection with the SyncMaster OTA. Okay. So if your configuration is correct, you can click the device and select the latest telemetry. So you can see the value uploaded by NodeRED and the display here. So you can see we have the 5 values. Okay, the battery status is 0. Means the battery is no error. Okay, no error. So the value is 0, and the battery voltage is 3.62 voltage. And the car status is 1, and the ultrasound the status is 1. Means the sensor detect there is a car parking here. And the height is 131. It means the distance between the sensor and the car is 13.1 cm. Okay. So we can use the dashboard and added a new dashboard to review this value in different way. So you can see we have already added the dashboard, the parking sensor, and we click OK. So you can see the 5 value displayed in the graphic. OK. So it's more easy to understand. So of course you can add the more and more. We call this is the widget. You can add your own widget as you want. You just click the pencil icon and click the add the new widget and create new widget. And we can select, for example, we can select the digital cookies, and we select okay, this one, and click the edit and select the parameters, the parking sensor, and select the time series. Okay, so for example, we want to watch the battery voltage. Okay, so we click the add. Okay, so you can see it's happened here. It's displayed here. Okay, so of course you can modify this cookie in advance. So for example, you can change the minima value and the maxima value. Okay, and you can also change the name of the widget and change the color, and you can change the value by check the use data post processing function here. Okay, so in summary, you can edit the widget and configure the widget here. Okay, and after your configuration, you just click apply change, so you can see you will display in the same master OTA. Okay, so this is our demo topology today. Okay, thank you.
Okay. Well, as we know, time limitation, tend to go into the too much the detail about some technical. Later, we will put some explanation in our presentation slide to share all of the after. Here is today's demo. It's today's topic. Today's topic. We introduce about the WebMaster smart parking solution, including NB-IoT and LoRaWAN solution. WebMaster provide Walmart provided the smart parking sensor ES102 series, the LoRaWAN gateway WR32. Furthermore, a demonstration about the LoRaWAN parking sensor solution. Any questions? Okay, if any question, please feel free to mail us. Thanks for your time to join. See you next time. Bye.